How do we prepare astronauts for the journey into space? In the 1960s and 1970s, engineers built mission simulators, full-scale spacecraft surrounded by massive optical visual systems.
As with all of NASA's robotic missions to the Moon, the flight path of the manned Apollo spacecraft was calculated and controlled by computer, from launch to touchdown, all watched over by a room full of technicians. However, when it came to Apollo, it wasn't limited to screens and pages full of numbers. The progress of each mission was itemized in flight plans that included computer-generated drawings of what the passengers could expect to see through their cabin windows along the way. Though basic compared to what is possible today, it was, no less, a result of the same physics and maths. Those same calculations were used to reproduce real-time images in the Command and Lunar Module simulators, which was no mean feat in the years before CGI. The principles of LOLA, the Lunar Orbit and Landing Approach Simulator, were outlined in this document. It describes a method of combining images of spacecraft, stars, and the lunar surface using beam splitters. The concept was brought to life in a number of Apollo Command and Lunar Module simulators, where projection boxes were bolted over the cabin windows of actual spacecraft.
Astronauts were put through multiple simulations in preparation for the Apollo 11 mission. NASA tapped the Army Map Service to build the Lunar Module Simulator to create a near-perfect illusion of landing and taking off from the Moon. This simulator was painted using sophisticated airbrushing techniques.
The lunar surface models included a complete 20-foot diameter moon and 3 15 by 40 feet relief maps. When illuminated, these maps looked like the real thing. Cameras mounted on various platforms were able to capture realistic views of the lunar surface at the current latitude, longitude, and altitude, while taking into account the orientation of the spacecraft, everything faithfully reproduced, right down to the spacecraft control panels, and all under the control of a computer. The view was rear projected onto a wide-angle screen. To complete the illusion, a light illuminated a starball to superimpose the size and relative position of stars on the image using a beam splitter.
Mirrored reflections of ball bearings embedded in black spheres generated the three-dimensional star field so perfectly that astronauts called it the next best thing to looking out the spacecraft window.
However, there was a drawback to this design. Bright stars below the horizon were still visible against darker areas of the lunar projection. For example, in this sequence you will notice a white spot quickly enters the scene from the bottom of the screen and dances around independently of both camera field of view and the lunar landscape. It is accompanied by a second, slightly less visible spot that maintains its position relative to the first. But look closely and you will see they are in fact part of a four-star formation that retains its shape wherever it is in the field of view. And it's not just stars that get reflected. In this sequence, what looks like a shiny metal letter O is clearly visible at the bottom of the screen here, and once again as the operator moves his arm out of the way here. Let's be clear, these artifacts are no more a part of the spacecraft or lunar surface than they are dirt or reflections on the cabin window or camera lens, because they can be seen to act independently of those surfaces. Not that these minor details should matter on a simulation. Except these sequences are in fact excerpts from a live TV broadcast as Apollo 11 orbited the moon hours before landing.
We are in fact about to see more pictures now from of the lunar surface from Apollo 11. With me here in our space headquarters in New York is our science editor, Jules Bergman. Jules, these should be interesting shots.
Frank, Apollo 11 is now on the near side of the moon, coming up on the Sea of Tranquility, the landing area where Armstrong and Aldrin are scheduled to land tomorrow at an altitude of 102 miles, and we're just getting the TV picture. Let's go to it for Apollo control.
Earlier was Neil Armstrong. Major Schumer. And Gilbert U is in the center right now. And this comes up at about a little over 12 minutes before power descent. We can start looking.
Incredibly, a video of the same sequence on the official NASA Apollo Flight Journal page has been re-recorded to obscure the shiny artifact. Here, the camera has been zoomed in to clip our view of the inexplicable item at the bottom of the screen. You can tell by the location of that permanent white dot. And yes, it is deliberate. Once this embarrassing incident has passed, the cameraman zooms out to show the original broadcast TV picture in its entirety.
Say it's only a paper moon sailing over a cardboard sea, but it wouldn't be make-believe if you believed in me. Yes, it's only a canvas sky hanging over a cotton tree, but it wouldn't be make-believe if you believed